All right, the next word we're going to look at is the word intersection. Now, when we're talking about an intersection, we're usually talking about two lines that intersect, and they're going to intersect at a single point. So we have an intersection, and it's intersecting at a single point. And we're just going to call these lines M and N. And remember, we name a point with a capital letter. So, point P is the intersection of line M and line N. Now, when we're talking about a line, there is no measurable measure for a line because it goes forever in both directions. So when we're talking about in geometry, we're going to be talking about a portion of a line. And we're going to call that portion of a line a line segment. And a line segment is just a portion of a line. And it's measurable. So if we're talking just about a measurable portion of a line, we're going to still have our 2 points named with a capital letter, in our case A and B. But A and B are known as endpoints. They're the points on the end. And like a line, we can call it line AB, but this time we're just going to put a bar on top of AB. A bar on top of BA. And remember, we're not prejudiced. AB is the same as BA. Now, of course, we can have multiple line segments with different measures. But we can also have them where they are congruent. And these are known as congruent line segments. Now, we're obviously and have to be talking about more than one here. So let's call this AB and CD. Now we can denote or identify these as congruent in 2 ways. The first way is we could say AB is congruent to CD. And I want you to note that this little symbol means is congruent to. Okay? Is congruent to. And of course, there's an easier way to denote 2 lines congruent by just putting a simple dash through them or a little hash mark. And you can identify multiple congruent lines by adding more hash marks. So we would be able to identify that AB is congruent to CD, knowing that both are congruent by the number of hash marks through each line. Now, the next and final concept of a line here is known as a ray. 2 things that identify a ray. It has one endpoint has one endpoint and it extends in one direction forever. So, have an endpoint, which we will call E, and it's extending forever in one direction through point A. Now, array is one of the times in which it is important that you name it correctly. To name array, if we draw an arrow, which is going to be the top of our name to identify that it's in fact array, I want you to note that the endpoint comes first. So we have to make sure we identify the endpoint E and through the adjacent point A. So we always start with the endpoint and then the adjacent point A. If you named it AE, that's a totally different ray. Now, we're not talking completely about line segments now. We're going to move up to angles. Now, an angle is two rays that share a common endpoint. So if we're finding a common endpoint, whatever my endpoint is, we're going to have two separate rays sharing that endpoint. So here's my endpoint, and here's EA, and here's EB. Now, angles have different parts. And the first part I want to identify is this section right here. This is known as the interior of the angle. And I want you to note that it's on the inside part of the angle. Now, if you have an interior, which is on the inside, you can also hold true that there's going to be an exterior as well. And the exterior is going to be on the outside of the angle. So we have the exterior part of the angle. Now, of course, there's some more things you need to know about the parts of an angle. And the first thing is the two rays. Not only are they rays, but they're also called sides. And the endpoint is known as a vertex. Now, there are different types of angles, of course. different types of angles. The first one is known as an acute angle. Acute angles are usually identifiable by the fact that they measure less than 90 degrees. And a little bit more mathematical, the measure in degrees of an acute angle is going to be thus 0 is less than x degrees, which is less than 90 degrees. So it's between 0 and 90 degrees. Our next type of angle is known as an obtuse angle. Now, our obtuse angles are opened wide, and we usually generally know that they are greater than 90 degrees. But a more mathematical generalization is that 90 is less than x degrees of the obtuse angle, which is less than 180 degrees. Now, there are two more types of angles important in geometry. The first is a right angle. A right angle always measures 90 degrees. We usually denote it or identify a right angle with a square corner, and we know that it equals 90 degrees. And our fourth and final angle is known as a straight angle. And it's always measures 180 degrees.